So okay guys, so in this session we will see how to delete the node. For creation we require malloc, memory allocation function. Similarly for delete, what we require is a free function, right? So in this program we're going to delete the first node. Okay, tell me the logic theoretical concept. If I delete node, what is my first node? Then if I delete this becomes my first node. So first pointer should always point to the first node of a linked list. So what we're going to do, we're going to take a pointer, we will assign the address of first node to that pointer, we will free that pointer and we will move first to the address of second. A very simple program. So for this what we need, let's suppose write a function void delete underscore first node, right? So I am taking a pointer, I am writing struct node star ptr, right? So after this what I am doing, I am writing ptr is equal to first. Now my ptr is pointing at what? Address 100. So now this is my ptr. Now guys tell me, if you are going to delete this node, this becomes my first node. If this becomes my first node, my first pointer should always point to the first node. So you want your first to be pointing to 200. So what is 200? 200 is nothing but length part of this ptr is 200. So ptr arrow length, which is 200, you're gonna assign this 200 address to your first pointer. So now after this line, first is now this connection breaks. Now your first is pointing to what? 200. Now when first is pointing to 200, this connection breaks, right? And this you have to basically delete. This node you have to basically delete. So this is what? 100. So what for deletion what you use? You write free. So you write free ptr. That's it. And this gonna delete this node. Fine, no issue. I'm again repeating. So what I'm doing, I'm taking a pointer ptr. I'm assigning this pointer to the address of first node. So now when I write ptr is equal to first, now my ptr is pointing at what? 100. Now suppose if I want to delete this node, my first pointer should point to the next node, and address of next node is 200, and 200 is what? Link of ptr is 200. So after deletion of this node, the first should point to 200. So I am writing ptr link, this is 200. I am assigning this 200 to your first pointer. Now first address is 200, first is pointing to this. So this connection breaks. Now this is free. You're going to delete this. So this is nothing but your ptr. So write free ptr. So this will delete the first one. After this, let's write a code for deletion of last node. Now let's write a code for deletion of last node. Deletion of last node. Let's suppose this is my linked list. This is the first pointer which always points to the first node of a linked list. This is info part and this is link part. So now tell me guys, now if I want to delete this node, if I delete this node, tell me what all addresses are important. Since I want to delete this node, I want to reach to this. This is important. Fine. So let's suppose this is ptr. Now once I delete this becomes your last node. Now if this becomes your last node, then the last node should be what? It should be null. So this I have to make null. So null this part, link part of 200. So for me this address is also important, cpt. So how many addresses are required? 2 addresses are required. One is 300, one is 200. Now since it's a single link, this is only forward. It moves only forward. It cannot move backward. So from 300 you cannot get 200, right? From 300 you cannot get 200. Therefore I require one more pointer which should point to the address 200. So how many pointers to be required in this case? 2 pointers. So let me write a code for this. So let me write a function void delete underscore last node. So I am taking 2 pointers, struct node star ptr comma star cpt. Now I want to move the pointer to the last point, and you know the standard code which I told you. You write that ptr is equal to first. So initially my ptr is pointing at what? 100. Now I will move this point. I will write while PTR not equals to null. So I told you when you wrote this code, your PTR was pointing to what? Null. But we do not want my PTR to point to null. I want my PTR to point at what? 300. So what you will write? You will write PTR arrow length should not equal to null. So remember this. Right. So when PTR arrow length not equals null, I am going to move my pointer PTR is equal to PTR arrow length. Fine. Now when I debug this code, so what is PTR length? PTR length is 200. 200 not equals null, condition true. PTR moves to 200. 200 length is 300 not equals null. PTR moves to 300. 300 length is null. Null not equals null, condition false, and you will come out of the loop. So at this point of time, your PTR is pointing at 300. Now you want one more pointer which should point to 200. Now guys, tell me a very simple logic. Now when you write PTR arrow length not equals to null, so what is the value of the PTR arrow length? Right here the PTR arrow length is 200. Right? Now 200 not equal to null. When I am coming here, PTR is equal to PTR arrow length. PTR arrow length is 200. This 200 is getting assigned to PTR. So here the value of PTR is 200. Tell me what is the value of PTR at this empty space? What is PTR in this empty space? See, PTR is not 200. PTR length is 200. I am not assigned the 200 to PTR. So at this position, my PTR is not 200, but my PTR is 100. Why 100? See, I am simply checking PTR arrow length. PTR arrow length is 200, but I am not assigned this PTR arrow length to PTR. I have assigned this here. To here the value of PTR is 200. But what is the value of 100? Why 200 here? Because PTR was pointing at 100. 100 length is 200. So at this point of time, at this blank space, the value of PTR is 100. So you have taken one more pointer CPT. So why not do one thing? Take the address PTR, which is nothing but 100. At this point PTR is 100. You want to take this address 100. You want to assign this 100 to a variable called as CPT, which I am taking here. CPT is equal to PTR. Now when you write this code, while PTR arrow length not equals to null, CPT is equal to PTR, PTR is equal to PTR arrow length. Again, let's run this code. PTR arrow length is 200. 200 not equals to null, condition true. CPT is equal to PTR. Since the value of PTR is 100, the value of CPT becomes what? 100. Now PTR is equal to PTR arrow length. Since the value of PTR is 100, PTR arrow length is 200. 200 gets assigned to your PTR, so value of PTR becomes 200. Now again, you run the loop. 200 length is 300. 300 not equals to null, condition true. CPT is equal to PTR. Value of PTR was 200. So CPT becomes what? 200. And PTR is equal to 200 arrow length, which is 300. Again you run the loop. 300 arrow length. 300 arrow length is what? Null. So null not equal to null, condition false, and you will come out of the loop. So at this point of time, your CPT is pointing at what? 200, and your PTR is pointing at what? 300. Your CPT is pointing at 200 and your PTR is pointing at 200. So remember that this is the set code, which makes sure that one pointer points to the last node and one pointer points to the previous node. So this is the code for that, and you're going to use this code in many more examples of linked list. So now CPT is pointing at 200 and your PTR is pointing at 300. Now it becomes very easy to write a code. What you guys have to do? You have to make sure that link part is null. So what you will write? You will write CPT arrow length is equal to what? Null. So this becomes null. After that, this connection breaks and this becomes a separate identity which you're going to free. So you simply write free PTR. That's it. Thank you guys, and please don't forget to subscribe my channel, and please do like and share. Thank you so much.